Hi dear students. So in the last class we had discussed about the conservation of momentum and as well the equilibrium of the particle. Now in this section we will discuss about the major forces in mechanics, mainly the gravitational force. We can say the gravitational force is the universal force. And we have already studied that things in the first chapter. That's the gravitational force is always being an attractive force, and it is one of the weakest force comparatively compared to the other forces. The gravitational force is one weaker one, but the range of action of gravitational force, it is infinity. So already we have studied about the gravitational force. Now due to this gravitation, some other sub forces are there. That is the contact forces. Contact forces include the frictional force and as well the tension. All those forces are due to the contact forces. And the buoyancy is also one of the contact force. So what are contact forces? So as the name reveals, if two bodies are in contact, so due to that contact, if there is any forces in between those two bodies, such forces will be known as the contact forces. As we have seen, when you are keeping a notebook or a textbook on a table, so there will be a contact in between the surface of the table and the book. Due to the gravity, there will be a force acting towards or on the table by the book, and as well the book is acting or book is on the book. There will be a force due to the table, that is the normal force. So that both of those forces can be named as the, or they are in the category of the contact forces. So the definition for the contact force: a contact force on an object arises due to contact with some other objects. So solid as well the liquid, fluids, all those things can be show the contact forces. In all those mediums, the contact forces can be happen. So the examples are also given. The book is resting on the table, and as well the rigid body is connected to a rod, hinges. So those kind of forces, the hinge, if the body is hanging on a rope or as well in a hinge, such forces are known as the tension forces. As well, in between the solids and fluids also, between solid and fluid, the contact forces can be possible. The buoyancy of the water, the force due to the buoyancy. Suppose if you are dropping a wooden piece over the water, it will float over the water, isn't it? So that is due to the buoyancy of the water. Actually the water surface is applying a force against the wooden piece, so that's why it is floating over the water, and that phenomenon is known as, or that force which is applied by the water over that or on that wooden piece is known as the force due to the buoyancy. So all those things are very important. Now the tension. So tension on a string as well, the force due to a spring. You know that if you are applying a force over a spring, that means if you are just compressing it or if you are elongating it, there will be an opposite force acted by the spring to retain its original position. A restoring force will be there. If you are compressing the spring, it will tend to elongate, and wherever its normal position, normal shape, it will try to reappear in its normal shape or normal position. So that is known as the restoring force. The spring force on the basis of the displacement happen, we can define the spring force as F is equal to minus K into X, where F is the force which is exerted over the spring, or which is the restoring force by the spring, and K, that K is known as the spring constant, and X is known as the displacement happened due to the due to exerting the force F. So F is equal to minus K into X. That equation is an important one, that is the spring equation. Remember that one. Now, if you are considering an inextensible string, the force constant will be very high, and the restoring force in a string is known as the tension. As the spring, whenever you are hanging a body on a string, there also a minute elongation is happening, but it is not being visible through the naked eyes. When you are doing that Young's modulus experiment, then you will understand that one. So there are also some restoring forces in the case of the strings also, as we are elongating, or if you are applying or if you are hanging a body, a weight over a string, then it will elongate and it will tend to reform into its natural or original position. That restoring, that the force which is trying to restore it is known as that restoring force, and that restoring force is commonly known as the tension. And this tension assumption is normally useful for only the strings with a negligible mass. Okay. So we can characterize the contact forces into many types, but if we are coming to the nuclear level, all the contact forces are arise due to the electromagnetic or electrical forces. If you are considering at a microscopic level, all the bodies are made up of charged constituents or the charged particles, the nuclei and the electron, all those things. So, and the various contact forces are arising due to the elasticity of these bodies, molecular collision and impacts. So ultimately we trace to be electrical force between the charged constituents of the different bodies. So on the microscopic level, if you are considering, all these contact forces are raised due to the electrical forces or the electrical phenomena that we are taking in between the bodies. Okay. Now come to the major portion, that is the friction. So friction, you know that friction is one of the contact force, and if two bodies are come in contact, and if one of the body is starting to slide or move over the other body, then there will be a resistance applied by the second body over the first one. And vice versa also we can say that the opposite applied force by the second body on the first one is known as actually the frictional force, a resistance to the motion, or the relative motion. We can say the relative motion, the resistance to the relative motion between two bodies are known as the friction. If we apply an external force on a body at rest in horizontal direction, the frictional force will be in horizontal direction and opposes the applied force. Suppose if you are keeping a notebook on the table, and if you are pushing it with a very small amount of force, then you know that it will not move. That means the frictional force in between the book and the surface of the table is more than the force that you have applied. So you have to apply a necessary amount of force that is slightly more than the frictional force. Then the book starts move. So resulting in zero net force. So if you are applying a less amount of force than the frictional force, the opposing force, then the total amount of the force will become zero. And the frictional force will be always in the opposite direction of the motion, or we can say the applied force. Now, if there is no applied force, we are not pushing the notebook. Okay, that means our pushing, that is known as the applied force. If there is no applied force, there will be no friction, and the friction will come into play whenever we are applying an external force. And if as the applied force is increases, then the frictional force also will increase. And at a particular time, the frictional force and the applied force both will come in, or both will become equal. If the mass of the body is m, then the normal force acting will be is equal to mg, that is capital N. And the coefficient of the friction, or the static friction between those two bodies, if it is mu s, then the frictional force, the static frictional force Fs will be is equal to mu s into N. That is the relation between the, or relation to obtain the frictional force. Where the constant mu s is called the coefficient of friction. This mu s is known as the coefficient of the prism. So the law of static friction can be written as the frictional force should be less than or equal to mu s into N. So if the frictional force become more than the mu s into N, that is means applied force, then our statement will become wrong. So the frictional force Fs should be always less than or equal to the mu s into N. If the applied force F exceeds, that means the applied force, that means external force we are increasing, then for a particular moment the Fs max will reach, that means the static frictional force, the maximum value of the static frictional force. And thereafter if you are applying an excess amount of force, then what will happen? The body will start move. So it is found experimentally that when relative motion has started, the frictional force decreases from the static, that is the maximum value, to some another values, and the motion, the frictional force due to the motion, it is known as the kinetic friction. The frictional force due to the motion, it is known as the kinetic friction, and it is represented as Fk. And there is, as you have seen in the case of the static friction, the Fk will be is equal to mu k into n, where mu k is the kinetic friction coefficient. So some of the major aspects regarding the kinetic friction force Fk, where the mu k is the coefficient of the kinetic friction, and which is depending only on the surface in contact. The mu value depends only on the surface in contacts, and the mu k value will be always less than mu s. We have discussed that one. The frictional force, the static frictional force will be always greater than the kinetic frictional force. So the mu s value will be greater than mu k. So if you are considering a body which is moving in this direction, in the left to right direction, by an applied force capital F, and there will be an opposing force, that is Fk. So the resultant force will be F minus Fk. F minus Fk. So that is the resultant force. And then if you want to find out the acceleration value, as we know F is equal to ma, so here the F means F minus Fk, which is equal to m a. So a value, acceleration value, if you want to find, then F minus Fk divided by m will be the acceleration, the maximum acceleration value. So if the applied force on the body is removed, its acceleration is minus Fk by m, and it eventually come to stop. So we are removing the applied force. Solely the frictional force will be there in action, and that will be also in the negative direction, the opposite direction of the motion. So there the acceleration value you can find out as minus Fk divided by m, where the capital F will be is equal to 0. Okay. So now we are having the example questions. We have to discuss those example questions. That are some of the important questions. You just go through that example questions once you just go through that one, and in the coming classes we will discuss those example questions, and prepare very well. Okay. So thank you.